We present a system for automatically capturing well-composed video footage of two people in the real world in real time. Here you see a variety of shots captured using our system. Our system composes static shots based on principles from cinematography literature, and produces transitions between these static shots using a novel trajectory planning algorithm. We capture these shots and transitions autonomously using a single quadrotor camera. To build our system, we consider four major design issues. How do we track the subjects in the camera? Where do we place the camera to capture the scene? How do we ensure safety of subjects? How do we transition between shots? Our system finds the pose of subjects in camera using active trackers. We use RTK GPS and IMUs to provide centimeter-accurate tracking. Next, we plan stationary shots using the tracked poses. We use canonical shots from traditional and virtual cinematography, such as the apex, external, and internal shots. Since quadrotors can be noisy, annoying, or even dangerous, we enforce a no-fly zone around each subject, which we call the safety sphere. In this case, we push the camera position out of the safety sphere and zoom in to approximate the original framing. We want to plan paths for our quadrotor that transition the camera framing between these poses in a visually pleasing way, while still observing the safety sphere constraints. We propose a novel real-time trajectory planning algorithm to find such transitions. See the paper for details. Here is a virtual representation of a shot our system plans. In this apex shot, subjects are horizontally centered and their eyes placed 1/3 of the way from the top. The captured footage matches the planned composition, obeying the so-called rule of thirds. Here is a shot which had to be moved back to avoid the safety sphere of the near subject, along with the suggested crop. Here is a range of shots from a single flight. Notice our shots respect the line of action, placing both people on the same side of the frame across subsequent shots. In addition to capturing unscripted behavior, we also use our system to film choreographed dance. Here's a transition to an apex from above. Notice how the crop smoothly changes, zooming out to let the shot fill the frame. Here's a transition from one external shot to the other. Notice that the start and end poses are both nicely composed and intermediate framings transition smoothly. Here you see this transition captured by our system in the real world. Our transitions allow us to move the camera without missing any of the dance. On top of that, the transitions add to the dynamic feeling of the action. Here are more virtual transitions. Notice how across these various transitions, the visual compositions remain reasonable. In this third-person view of our system in action during a transition, you can see how the quadrotor respects the subject's safety spheres by moving in an arc around them. Here we show the behavior and screen space of accurate versus conventional GPS. The position of the textured characters is determined by the RTK GPS system. In comparison, the position of the gray characters is determined by fusing a single-point GPS, barometer, and IMU. At 10x speed, you can see the gray characters drifting drastically over time. Here is an external shot planned using the low-accuracy tracking system. The more reliable RTK GPS locations reveal that this shot is not correctly framed. Conventional GPS is too unreliable for shot planning. Prioritizing safety does impact visual quality. In this internal shot, the camera can be up to 12 meters away from the subject, requiring an extreme crop when using our fixed focal length wide-angle lens. In these situations, our system's orientation and control error results in poor crop suggestions. However, since the suggested crop is always in the center of the frame, we can still manually adjust the crop at the time of editing to produce a reasonable framing at the cost of lower resolution. Quadrotor cameras equipped with zoom lenses could provide greater resolution. Lastly, here's an edited montage of a simulated graduation ceremony created using our system. We show that our system can support capturing two subjects acting out a more involved scripted sketch. These shots are able to aid in the storytelling of a short narrative. With an editor's hand involved, we can produce these nicely manually cropped close-ups. In summary, we present the first system for automatically capturing well-composed videos of two subjects in the real world incorporating rules of visual composition. We imagine this system will be particularly helpful for novice cinematographers. However, our system can also be used by expert pilots to line up a shot before they take over manual control of the quadrotor. Thank you for watching.